Assalamu alaikum. This is the phase two submission of our project to discuss subgraph isomorphism for football analytics using Oberoi's technique. But first, we need to understand the input dataset of matches. The input dataset models football matches as dynamic graphs. Each player is a node connected to another node, and their passes are directed as shown using directed edges with attributes like timestamps and pass success rates. This setup helps us to understand the evolving nature of passing patterns during a match and enables us to analyze these over specific time intervals. And by treating each snapshot as a discrete moment in time, we can track these changes and identify patterns in different team strategies. But to do this, we also need to segregate passes of one match from another match. And Oberoi's method organizes match data into temporal snapshots using timestamps. Each snapshot represents the network of passes within a defined time interval, which isolates the dynamic of one match or match from another. And to better understand this, what we can do is that if there are two matches being played, or we could say that there are two passes occurring at the same timestamp, then that means that those two passes by the team were made in different matches. And by understanding this and by understanding that these matches do not overlap, this preserves the overall integrity of the each match's uniqueness. And by structuring the data this way, we can analyze individual game strategies and compare these patterns across separate matches. As mentioned in the previous phase, Oberar's code uses the existing VF3 algorithm and modifies it to detect this subgraph isomorphism. However, Oberoi's code requires a list of nodes with attributes and edges between nodes and their respective attributes such as timestamps. This overall allows to have a flexible representation of these networks and in our case, football matches. But to change our input to the desired input of Oberoi's code, first we need to pre-process this data to convert football matches into the required format. Players have to be mapped to node IDs and passes and encoded as direct edges with attributes like success rates and timestamps. Secondly, this structured data has to be segmented into temporal snapshots, and we need to capture interactions during specific time intervals. This ensures that the graph inputs are aligned with the overall nature of the problem. Thirdly, and most importantly, we need to use these formatted snapshots and feed into the existing VF3 algorithm proposed by Oberoi. And this would help us to identify the recurring subgraph patterns, the passing formations or different team strategies played by a team in different games. And this overall code technique helps us to bridge this real world football data and Oberoi's framework and enables us to identify the effective strategies and provide us a better understanding of a team's dynamic behavior.
Okay, so now let's understand how the code works here. So firstly, we have a basic data type called pass, and here we have the start time, end time, and the sender and receiver of each pass. We'll use this pass data type to further use this to process our data. Here we have a function called load data where we basically take the file name as an input and we load that file. And we have a list of passes for the data type pass. Next, we firstly obviously ignore the header line of the data of the CSV file, and then for each line, we process the data. In the processing, we have four main properties: the start time, end time, the sender and receiver of each pass. We get each line and we process it and store it in our main pass list. Next, we have to get each pass. Basically, we'll extract the passes for each single match and we'll send it to our list. So here, for what we do is we basically check if one of the sender of one pass is the receiver of the previous one. So for example, we're checking pass number two. We see if pass one has been sent to the person who is doing pass number two. That way we can create a link between the two. Allows us to see the progression between a single match. Next, we'll print the info of each pass. We'll give it the total passes of the match and each match name, and we'll print the data of each match as well as the total count of the number of passes as well as the total number of matches. Let's run the code to view this property. So here, as you can see, we have all 14 matches, and for each match, we have the information of each pass. For every pass, we have the start time, the end time, the sender and receiver of that particular pass, and lastly, we also have the total number of matches and the total number of passes as well.
In the code that we have been provided gives us an analysis of the team strategies based upon the passes that they have made, and gives us a way to decode the game. Now, the information to us has been provided in a CSV file, which contains the starting and the ending time of each pass, as well as the person who sent and received the pass. Based upon this data, we can group them into logical sequences and analyze the gameplay dynamics. In the data, we have a total of 133 passes, which are spread across 14 matches, which gives us a roughly about 14 passes for 10 to 14 passes for each match. Moving on, as mentioned before, we can group them based on sender and receiver continuity and timing. We can see the pass distribution is between 10 to 14 passes for each match, and using this data, we can delve into the team's strategies and gameplay flow. Now, if we analyze the data, we can see that Team A has a possession based gameplay with structured passing sequences where player 18 acts as a central playmaker and orchestrates the team's movements, while Team B utilizes direct play and counter attacking with shorter passing sequences, and players 7 and 14 share responsibilities and lead the team. Moving on, we have a strategic comparison based upon the data that we have gotten from the program. We can see that the team A has a higher pass volume, while team B has a lower pass volume, which fits into their play style, where team A is more focused on possession and calculated build up, while team B is focused on direct play, quick transitions, and reactive movements. And the team A's tactical focus is on control and patience, while team B has focuses more on speed and opportunistic attacks. Moving on, the actionable insights that we have gotten, the way the teams can improve is as follow. The team A can improve by enhancing versatility. This can be done by reducing dependence on player 18 and developing faster transitions, as well as encouraging other players to think for themselves and not just depend on one player for everything. While on the other hand, for team B, it can be done by improving control, which means that they can try to enhance their possessions through low intensity periods and refine their counter attack strategies. The both teams, however, can basically adapt and evolve and use these insights to refine their tactics and improve their overall team performance. Now, the conclusion that we get from this program is basically it provides us a deep insights into team dynamics and the strategies of the teams. It also has a lot of practical applications, as coaches can use it for refining their tactics, see the areas in which they are lacking, tell them to their players, and focus on improving in those areas, and they can use this to improve their performance, as well as regular analysis allows teams to adapt and stay competitive. Thank you.